All right, let's talk about one of the biggest, most mind-blowing ideas in all of physics, quantum field theory. Seriously, this is a concept that completely rewrites the rulebook for reality itself. So let's just dive right in. So, have you ever really wondered what the universe is made of? I mean, what are the absolute most fundamental building blocks? We're not talking atoms, or even the protons and electrons inside them. We're talking about the stuff that makes all of that possible. Well, quantum field theory is the closest thing we have to an answer. And to even begin to grasp it, we have to basically throw out our everyday common sense idea of what a thing even is. So get ready, because the universe is about to get a whole lot weirder and, honestly, a whole lot more amazing. Okay, so our first stop on this journey requires a complete shift in how you see everything. Before we can even get to particles or forces, we have to talk about the stage where all the action happens. And that stage? It's a field. So, what is quantum field theory, like by the book? Well, it's this incredibly powerful framework that manages to combine two absolute titans of modern physics. You've got quantum mechanics, the bizarre rules of the super small, and you've got Einstein's special relativity, the physics of things moving incredibly fast. When you smash those two together, you get QFT, which is our best description, period, of how reality works at the ground level. Now, here's the absolute key takeaway. I want you to completely erase that image in your head of tiny, solid billiard balls bouncing around. The most fundamental ingredients of our universe aren't things at all. They're these invisible, energy-filled fields that stretch across every single point in space and time. There's an electron field, a quark field, a light field, a separate field for every fundamental particle. They're everywhere. Okay, so if everything is a field, then where the heck do the particles that we actually see and measure, like electrons and photons, where do they come from? Well, this next part, this is the real heart of QFT. I want you to just picture a perfectly still, infinite ocean. It stretches out in every direction, completely calm. This is the field in its lowest energy state, what we call the vacuum. It's there, filling everything, but it's quiet. So what happens if you just tap that ocean of energy? You'd create a ripple, right? A little localized vibration that starts to travel across the surface. A tiny, concentrated packet of energy. And here is the mind-blowing part. That ripple is the particle. An electron isn't some separate little thing moving through the electron field. The electron is a vibration of the electron field. Think about it this way. It's not an actor walking on the stage. It's a little tremor in the stage floor itself. And this idea, as simple as it sounds, applies to everything. That particle of light we call a photon, it's just a ripple in the electromagnetic field. The electron, a ripple in the electron field. A quark, you guessed it, a ripple in the quark field. Every single fundamental particle we've ever found is just a tiny vibration in its own unique universe-spanning field. Right, so particles are just ripples in their fields. But then how do they interact with each other? How does one electron feel another electron nearby and push it away? This brings us to what forces really are in this new picture. In the world of QFT, that whole idea of some mysterious, invisible force just reaching out and pushing something, it just goes away. Instead, forces are what happen when these different fields interact with each other. They're basically talking to one another. Let's walk through a classic example. Two electrons repelling each other. So you have two ripples in the electron field. That's our two electrons, and they get close. Their fields start to overlap. To communicate, they exchange a messenger particle, which is just a ripple in a different field. In this case, they toss a photon, a ripple in the electromagnetic field, back and forth. It's like two people in rowboats pushing each other apart by throwing a basketball between them. That act of exchanging the photon is the repulsive force. So this is a really cool story, a neat way to think about the universe. But is that all it is? A nice story? Absolutely not. This model isn't just an idea. It's one of the most successful, most precisely tested theories in the entire history of science. The predictions it makes are just mind-bogglingly accurate. And remember, the reason it's so powerful is because it combines the pure weirdness of the quantum world, where particles can pop in and out of existence, with the strict rules of relativity, like the cosmic speed limit of light and E equals mc squared. Fusing these two ideas together unlocks a whole new level of predicting how the universe behaves. I mean, this incredible combination is how we can explain some of the deepest secrets of reality. It's the reason antimatter has to exist. It's how we know that pure energy can literally create particles of matter, and how those particles can annihilate back into energy. It even gives us the famous Higgs mechanism, which is our explanation for where mass itself comes from. QFT is quite literally the operating system for modern particle physics.
In fact, our entire standard model of particle physics, our grand theory of almost everything, is built on the foundation of quantum field theory. It's the framework we use to describe three of the four fundamental forces of nature: electromagnetism, the weak nuclear force, and the strong nuclear force that holds atomic nuclei together. The only holdout so far is gravity, but that's a story for another day.
So let's just bring this all home. If you remember one thing, let it be this. The universe is not a collection of tiny dead objects. It's a cosmic symphony of vibrating, interacting quantum fields. And we, and everything we've ever seen or touched, are simply the music that those fields create. It is such a profound shift in how we view reality, and it leaves us with this incredible, lingering question. We've used this theory to discover things like the Higgs boson and to understand the fiery birth of the universe. But if everything is just ripples in these fields, what other secrets, what new particles, what other layers of reality might just be hiding out there, waiting for us to find them, as just another subtle ripple in the fabric of space-time?